The platform, which launched in Q3, has disrupted legacy workflows, reshaped the competitive landscape, particularly in enterprise software, and accelerated how teams communicate. That paragraph was generated entirely by a machine, and the clearest evidence isn't the corporate vocabulary, it's the punctuation. Today's language models write with a level of polish that frequently bypasses standard detection software. To spot an artificial author, editors and educators are increasingly looking for a specific typographical tell, an unusual, almost repetitive obsession with the em-dash. This preference carries actual stakes in the business world. Marketing teams are finding that their AI-drafted emails suffer drops in engagement because the prose reads as oddly stiff. When Nike posted a seemingly normal congratulatory tweet about tennis star Jannik Sinner that leaned heavily on the dash, they faced an immediate wave of user accusations, claiming they outsourced their social media entirely to a bot. The stigma is strong enough that professional human writers are actively editing out their own natural punctuation or deliberately inserting typos, simply to prove a person is sitting at the keyboard. No programmer explicitly typed a rule instructing the software to spam punctuation marks. This is an emergent behavior, a spontaneous quirk that developed on its own, and it reveals exactly how these systems actually process language. When you type a prompt, the system does not ponder the answer, it calculates it. It functions as a massive auto-predict engine, weighing the mathematical probability of the next word based on the billions of pages it ingested during its initial training. Early versions of these models were trained mostly on recent internet scrapes, and they rarely used dashes. But as developers scrambled for high-quality, sophisticated language to improve their outputs, they ingested massive libraries of digitized public domain books from the late 1800s and early 1900s. Writers from this specific era had distinct stylistic habits. Authors like Herman Melville frequently used the dash to extend thoughts, create dramatic pauses, or replace commas entirely. When the engineers mathematically graded these classic texts as a 10 out of 10 for quality, the software internalized a clear pattern. To emulate top-tier authoritative writing, it mathematically prioritizes the punctuation density found in books like Moby Dick, which contain dozens of dashes per page. There is also a computational incentive to choose this symbol. Language models do not read full words or letters. They process text in computational units called tokens, broken down word fragments mapped to numbers. The word, however, costs 2 separate tokens to process. A complex clause with commas takes even more. But the dash tokenizes as a single, highly efficient unit. From the machine's perspective, this single symbol is the ultimate shortcut. It aligns perfectly with the historical dataset's definition of elite prose, and it costs a fraction of the computational power to generate. Training data alone doesn't explain why models sound modern instead of speaking in 19th century archaic English. That final polish happens in a phase called reinforcement learning from human feedback, where thousands of human raters manually grade the machine's responses. Tech companies hired a massive global workforce of highly literate raters to sit at computers giving thumbs up or thumbs down to different outputs. These individuals brought their own regional vocabulary and professional biases directly into the grading process. If the machine generated 2 options, one that read like a dry academic textbook and another that had a snappy conversational flow, raters consistently gave the thumbs up to the latter. When raters saw an output punctuated with a dash, they didn't view it as robotic. They associated it with the polished, authoritative intelligence you would find in an editorial from The New Yorker. They liked the look of it, so they rewarded it. By consistently upvoting this specific stylistic flourish, human preference accidentally took a historical anomaly from the training data and baked it permanently into the software's final behavior. What started as a harmless punctuation quirk exposes a broader issue with synthetic text. The technology is now taking the chaotic diversity of human language and compressing it into a single homogenized register. This chart shows how varied formats of writing are converging into one standardized output. Because the system lacks a true understanding of context, it applies that exact same journalistic polish, whether drafting a casual Slack message, a dense legal brief, or a high school student's essay. Trying to fix this by typing "make it sound casual" rarely works. A simple tone adjustment does not alter the underlying mathematical weights that heavily prioritize those high-quality tokens. To genuinely change the output, you have to constrain the machine's available choices. The most effective method is a hard system prompt override. Before asking it to draft anything, explicitly instruct the model to avoid using the em dash entirely and to substitute commas or semicolons instead. For larger operations, teams are adapting by running automated scripts to find and replace the marks after generation. Editorial departments are even creating strict internal style guides that cap the number of allowable dashes in any AI-assisted draft. You don't need to intentionally add typos to your work or abandon your favorite grammar tools to prove you are human. You just have to stop accepting the software's default settings and start dictating your own boundaries.